Hey, what's up guys? Today we're going to look at an introduction to definite integrals. Okay, so to start, let's look at what exactly a definite integral is. So definite integrals are simply taking the integral except with endpoints. So the endpoints would be a and b of the function f of x dx. So with a and b, we're talking, what we're saying is if you have a graph and you have this graph right there, then a, and let's say this is a, say that's a, let's say that is b, and then the graph continues on doing something, whatever, doesn't matter, we don't care what the rest of the graph does. Anyways, we're going to take, this is what we're going to take the integral of between a and b, and we want to take the integral of anything below the graph if it's above the x-axis, or let's say we had a graph that goes, here let me draw another coordinate plane. Okay, so let's say we had a graph that goes like that, and we want to take the integral from here, and let's just say the graph keeps going like this. Oops. Disregard the part where it's like that, because that's impossible. But anyways, so from there to there, b. Okay. So the graph's like that. Okay. And this is b right here. Okay. So then, because it's below the axis, we're actually going to be looking at this part. And so I'll show you how to do that in an example towards the end. Okay, so that's what we'd be looking at, and we'd add those two areas together to get the total area. Okay, so to solve this, we're going to put it in the antiderivative form. We're going to take the integral. So then what it's going to look like is this right here is equal to the antiderivative, capital F of x, from a to b. So that's what the bracket and the two variable, or the two letters, which when you actually take the integral, those are going to be your starting point and your end point. So they'll be numbers. So that means that the integral has been integrated, but you haven't actually plugged in the numbers yet. And so this right here, f of x, capital F of x, from a to b is equal to capital F of b, capital F of b minus capital F of a. Okay, so basically you're taking the end and subtracting it by the beginning to get to know what's in between. Okay, so now let's go ahead and look at an example. In this example, we are going to integrate, so example 1, so we're going to integrate the function, the following function for x is less than or equal to, is greater than or equal to 1 and less than or equal to 4. So the function that we're going to use is f of x is equal to 3x squared plus 2. Okay, So step 1 is to write the formula. So if you remember, the formula is integral from a to b of f of x dx is equal to capital F of x from a to b, which is equal to capital F of b minus capital F of a. Okay. And then step 2 is to identify the pieces. So if you haven't seen my indefinite integration video, I would definitely take a look at that. Pause this and take a look at that, because I explain how we're going to identify. So basically, when you're integrating, it's the constant out front is a, and then you have the variable, so ax, and then the exponent is n, so ax to the n, and then constants go to 0. Okay, so identifying the pieces, first of all we need to remember our range. So between 1 and 4, and a is going to be equal to, let's see here, 1, and b is going to be equal to 4. So right here we're looking at a, so the beginning of the range, and b, which is the end of the range. Okay, and then so this is a different a than what I explained in indefinite integration. It's you can call it any variable you want, really. You could say from m to n or something, or from y to z. It doesn't really matter, but just don't get that confused. Okay, so then step 3 is plug and chug. So still on example 1, step 3. Let's plug and chug. So let's go ahead and write and plug in our variables, or pieces rather. So we have the equation, the function 3x squared plus 2 dx, and to solve, remember, we take the integral of the function first, so then we're going to have 3 over 2 plus 1, I'm only writing that for your benefit, 3 over 2 plus 1 x to the 2 plus 1 plus 2x, and that would be from 1 to 4. Okay, so that is equal, those are equal, those are the same thing, it's just been integrated. Okay, so then let's plug in. So what we do is we write this equation twice, and for the first one we write in the top number, and for the second one we write in the bottom one. So then we have that's equal to x cubed plus 2x from 1 to 4. Just show you the simplified version real quick. Okay, so then we have 4 cubed plus 2 times 4, and then we subtract the second one, so then minus 1 cubed plus 2 times 1. Okay, so then now let's simplify. So we have 64 plus 8 minus 1 plus 2. And then we're going to get 72 minus 3, which is equal to 69. Okay, so then your final answer, this is your final answer. So we can rewrite the original equation. So the integral from 1 to 4 of the function 3x squared plus 2 dx is equal to 69. And that's your answer. Okay, so let's go ahead and look at another example. This example is going to be significantly more complicated, and this is in this example I'm explaining or I'm showing you how to do integration when it's below the axis. So in this example 2, we're going to integrate the following function for negative 30 is less than or equal to x, which is less than or equal to 12. And the function we're going to use is f of x is equal to 1.2x cubed plus the cube root of x. So something to take note of is as with definite integration, if you have something below the axis or a negative limit, you can't have an even power because it will be imaginary, or rather if it's even fraction, the denominator of the fraction. So that's really the same as 1/3. So if, let's say we were taking a square root, we could not do a negative number. Okay, so then let's go ahead and get into the problem. So then step 1 is to write the formula. So the formula, again, is the integral from a to b of f of x dx is equal to capital F of x from a to b, which is equal to capital F of b minus capital F of a. Okay, so then step 2 is to identify the pieces. And in this step, we're also going to go ahead and simplify the function to make it easier to use. So to identify the pieces, and when I say identify the pieces, we're really talking about the range or the endpoints of the function. So right here, that's what we're looking at when we're identifying the pieces. If you need help again with integration itself, just plain old integration, take a look at my indefinite integration video because I explained that there. Okay, so then we are going to split this up into 2 integrals, so that way it's just a little bit easier to look at, to get your mind around. You don't actually have to, but it does make it easier. Okay, so then a1, so we're going to split this across the axes. So that's really negative 30 to 0 and 0 to 12 is what we're taking the integrals of. So a1 is going to be negative 30, it's going to be equal to negative 30. b1 is going to be equal to 0. a2 is going to be equal to 0, and b2 is going to be equal to 12. Okay, and then let's go ahead and simplify the function right here. So f of x is equal to 1.2x cubed plus the cube root of x. So that cube root can be simplified to take the following form. So 1.2x cubed plus x to the 1/3. And that just makes it easier to integrate. Okay, so let's move on to step 3. in step 3 of example 2, we are going to plug and chug. Okay, so let's go ahead and write the formula. So it's going to be a2 to b2 of f of x dx minus the integral from a1 to b1 f of x dx. So still and this is because it's going across the axes that we have the negative, but it's still end minus beginning. It's still taking the same form even before the integral because we're splitting it in half. Okay, so then let's go ahead and plug in. So we have 0 to 12, 1.2 x cubed plus x to the 1/3 dx. And then minus negative 30 to 0 of 1.2 x cubed plus x to the 1/3 dx. That should have been outside the parentheses, but it's not a big deal. Okay, so then let's integrate and get 1.2 over 4 x to the 4th plus 3/4 x to the 4/3, and that's from 0 to 12, and then minus the same thing, 1.2 over 4 x to the 4th plus 3/4 x to the 4/3, and that's from negative 30 to 0. Okay, so then we can plug in. So then we're going to have 1.2 over 4 times 12 to the 4th plus 3/4 times 12 to the 4/3, and then minus 0 because if you plug into 0, it's going to zero out. Okay, so I'm going to put a line through that to tell you that. Okay, so then minus 0 minus that, plugging the negative 30 in. So 1.2 over 4 times negative 30 to the 4th plus 3/4 times negative 30 to the 4/3, and close parentheses and close brackets. Okay, so then to simplify, we're going to get 6220.8 plus 9 cube root 12. So that, and then minus a negative 1.2 over 4 times negative 30 to the 4th plus 3/4 times negative 30 to the 4/3. Okay, and then simplify further, so 6220.8, and then I'm going to go ahead and combine these. So this becomes, so plus 243,000, so 243,000 is what this first part becomes. And then the next part, so then I'm going to write the plus 9 cube root of 12, and then plus 45 halves cube root of 30, and that's this last part right there. Okay, so then to simplify that into the final answer, we're going to get on the bottom here, we're going to get 30,520. So 30,520.8 plus 9 cube root of 12 plus 45 halves cube root of 30. And then, so this is your final answer, but if your teacher doesn't like all that jumble mess right there, because that's really not that useful to someone if they're actually trying to make use of it in the real world. So that's also approximately equal to 30,611.31759. So that is your approximate answer. Okay. I hope this video is helpful. If you need any further help or have any questions or anything, don't hesitate to contact me. I'll leave my email and website in the description below. See you.